As we stated, our learning target is that I can determine if a relation is a function and I can identify the domain and range. So let's jump right in here. So in our first question, we have this set of x values ranging from 1 to 4 and a set of y values ranging from 1.5 to 4. And it's asking, state the domain and range of the relationship, and is the relationship a function? All right, so you guys got a minute to think, pair, and share here in the class. If you're at home, you're just going to pause the video now and give yourself about a minute to do the same. Think, pair, share. All right, welcome back. How'd you guys do? All right. So hopefully you guys had some sort of um, connection to the previous lesson where we said that we can think about the domain and range as just fancy words for things that we already know. For example, car means automobile, automobile means car. Soda means pop, pop means soda. Domain means the x values. Range means the y values. We could throw input in for x values and output for y values. It's all the same. So the real question is not necessarily what the domain is, because here's the domain, boom. Here's the range, boom. Question is this a function? So let's get into that. Okay, all right. And as I said, we the domain is the x values between 1 and 4. Range is the y values between 1.5 and 4. The more technical way of saying it, all of the values of x that are equal to or greater than 1 or equal to the less than 4 are in the set. All of the y values that are greater than or equal to 1.5 or less than or equal to 4 are in the set. Now, the key point that I think is important is this does not pass the function test. And the reason, as you can clearly see, the function's multiple inputs are matched to more than one output. So we got port 2 here matched to 1.5 and 4. And we already talked about this is a violation. Mr. McCrae can't have a birthday on one date and another birthday on another date. Okay? It simply doesn't pass the test. So the same way that 2 is in violation, so is 3, and so is 4. All right, let's move on to the next question. All right, this is an interesting question. Let's talk about it. We got Jeremiah here. He's on a bike ride. The graph shows his bike ride. So let's look at it. So after 20 miles, he's been riding for 3 hours. After 40 miles, he's been riding for 4 hours. And after 60 miles, he's been riding for 9 hours. The question is now, what is the domain and range of the relationship? And is the relationship a function? And then they threw one at us also. State the interval where Jeremiah is running the fastest. Okay, guys, 1 minute is on the clock. Think, pair, and share in class. Go right ahead, go for it. And if you're at home, you know what to do. Pause this video and try to work it out on your own. All right, guys, welcome back. How we do? All right, so hopefully it was very clear that we're just looking at, for the domain, where is the smallest x value? Where is the largest x value? So we're in between 0 and 9, okay? Likewise, for our y, what is the smallest y value and what is the largest y value? And that's between 0 and 60. So, I mean, that all should have been pretty straightforward, okay? That should have been straightforward. Now, we're going to have fun with this in a minute. Get this out of the way here. All right. We are going to demonstrate a few things. So, for you guys at home, we're going to remember and copy down what you need to copy down, that the domain is the x values between 0 and 9, and the range are the y values between 0 and 60. Okay? All right, now, it's asking, is this a solution? And well, I kind of gave it away. It is. It passes the vertical line test. And so let's talk about what is this vertical line test, because it is a pretty nifty way of figuring out whether something is a function. Green line, ready. Okay. So as I pass this green line through this equation, I can verify it's a function because simply put, every x value only has one y value. Or looking at it more, graphically, the line only hits the green vertical line test one time. Now, if the line had passed through, if the vertical line passes through the function more than once, then it's not a function. But as you guys see, it only passes through it once. So that's a really nice test. Now, the final question had to be well, what is the fastest time? And I just think this is a really, you know, common sense way of approaching it. Take each line and line it up. Because ultimately, what we're trying to do is figure out, well, what is the slope? Is the slope less steep or more steep? So let's begin with these guys right here. Line this up. Now, when I do this, it kind of looks like that the purple line is a little steeper than the green line. So that means that this interval is definitely faster than this first interval. Now let me line up the brown line. Oh, okay. That's pretty convincing. What does that tell us? I'm glad you agree. It tells us that that last interval, that interval between here, is the interval time where he's the fastest. So what you want to do is you want to capture this. All right. So solution. Jeremiah rides the fastest or has the steepest slope between the third and the fourth interval. Okay, guys. It was fun. We'll be back for another installment shortly.